I am Samantha Jayasekara. My student number is 2105700. Our topic is IoT device security and privacy threats in residential smart meters and countermeasures. Uh, let's move to the traditional meter. Traditional meter meets the basic requirement of measuring the amount of electricity being consumed by an account. At the time of bill generation, the meter reader from company must physically check the meter and take a reading. In traditional meter drawbacks, a meter reader physically come to the customer's home or business place. If access cannot be gained to the meter, this may result in estimated bills. If a visit is not possible, the utility company must raise an invoice based on estimates. This can be disadvantageous for both the consumer and the company. Also, traditional meters do not store any data. No outweight detection, as distribution companies cannot react quickly to interruptions in their supply. Connection and disconnection must be done manually. In traditional meter, the human error will be happen due to meter readers' capability and accuracy. Traditional electricity meters only show the quantity of electricity consumed meter reader. Smart meters typically record energy real time and report regularly. Short intervals throughout the day, smart meters enable two-way communication between the meter and the central system, such as advanced meter infrastructure that is called AMI, differs from automatic meter reading that is called AMR, that it enables two-way communication between the meter and the supplier. Wireless communication options in common use include cellular communications. Smart meters effect on the environment also affect the environment. It helps the company distribute power according to usage trends and thus minimize wastage. A more balanced distribution of resources can also reduce the need to build new power plants.
Hi, I am Sudhirikku Hennathige Mayantha Hennathige. In this slide, I am going to dive into smart meters. Let's move to next slide. Here, I am going to talk about components of a smart meter. An AMI, Advanced Metering Infrastructure, is a set of technologies and applications that work together to produce a single system. The expansion of advanced metering infrastructure is viewed as a crucial step in modernization and transformation of existing electricity systems into smart grids. Customers can get real-time or non-real-time power pricing using this AMI, and utilities can get help with load reductions. AMI systems are made up of three main components. The three system is consideration now: customer data collection, communication network, and utility third-party data reception and management. The component of the AMI systems are divided into three sections. It shows in this figure. In the report, we have discussed about components of a smart meter more deeply. Let's move to next slide. In this slide, I am going to talk about smart meter vulnerabilities. We found a lot of vulnerabilities on smart meters when we were doing the literature reviews. The smart meter itself is a vulnerability to hardware and firmware reverse engineering. As Salman Kanji and Wajahat Ali Khan stated in their study, Smart Meter Security Vulnerabilities, Threats, Impact, and Countermeasures. As a result, the attacker will be able to steal information and evaluate access in order to exploit potential weaknesses. The attacker, on the other hand, will find a way to alter the control unit's circuit board. The attacker will able to remotely control the smart meter as a result of this. And Salman stated in his paper, Evaluation of Conventional Power System to Smart Grid, that a smart meter acts as a radio to communicate with data collector in the AMI. An intruder can intercept the data in the middle and steal it. Strike like the one on the Ukraine power infrastructure could occur as results of this kind of attack. The smart meter delivers real-time data to the data collector, who sends firmware updates and configuration in the meantime. In the report, we have explained all vulnerabilities that we found out through the literature reviews and about subcomponents of smart meters.
Hi, I'm Tilini, and we will take a look at the security threats and the vulnerabilities of the smart meter. So first, to elaborate easily, I categorized the threats in the findings of our research paper into three categories. So let's take a look at that. So these are the three categories that we are going to take a look. So first is vulnerabilities due to components. Second, HANO hand vulnerabilities and electricity theft. As Mayantha explained the components of the smart meter phase to individual threads, because these are several different components. For an example, the circuit board can be altered to steal information from the smart meter. The attack possibly escalate privileges to exploit possible flows of the smart meter. As the smart meter sends real-time data to the data collector, interceptions can be occurred in between. Malicious USB flash drives can be plugged to IHD to exploit attacks, such as rubber duckies. So second, we are going to take a look at HAN and vulnerabilities. So HAN is Home Area Network, and it has great security concerns with respect to other categories. The network can be poisons to malfunction the device. On the hand, we talk about several attacks, namely jamming attacks, malware attacks, replay attacks, and non-repudiation attacks. Most of these attacks can be avoided using security countermeasures. Last but not least, the electricity theft. Stealing electricity is common in developing countries. People steal electricity to reduce the consumption, to mislead the bill readings. So that's the electricity theft. Now, let's take a look at the countermeasures. To these mentioned threats. Most probably, the components-based attacks can be reduced using authentication. Using two-way authentication to identify the newly connected devices to smart meter will be a smart idea to overcome most of the vulnerabilities of the smart meter. Encryption and decryption RSA algorithms will tighten the security of the smart meter too. Jamming is difficult to offend, but the study suggests to alter the channels to prevent replay attacks. Smart meter can use packet numbering and session keys to avoid many more attacks. Electricity theft can be prevented using machine learning methods. This could be a little bit complicated, but including Gaussian mixture model, gradient boosting theft detection, electricity theft can be pulled out. So let's take a look at the future of the smart meters. The countermeasures must be implemented to safeguard the consumer data, and these smart meters must introduce to developing countries as well, because most of the electricity theft can be observed in developing countries. But there's a problem because of the expensiveness. The smart meters cannot be implemented in developing countries. Methods to prevent replay attacks must be implemented, as because there are no much ways to avoid that. And finally, there must be a cost-effective way to replace SMET 1 meters to SMET 2 meters. Thank you so much.